So now that we've talked a bit about what a Lambda expression is, let's summarize some of the benefits of using Lambda expressions. And we'll see how they can also work with multiple parameters and make the use of multiple parameters more compact than alternatives. And we'll take a quick look at this in this slide, and then we'll take a look at the example that shows it. So what are Lambda expressions good for? Well, they support very flexible and concise behavior parameterization. You're undoubtedly familiar with parameterization in general, parameterizing, passing data to methods. We're all very familiar with that in the form of classes and objects and so on. But now that you've got Lambda expressions and other forms of functional programming, you can actually pass them and make the methods parameterizable by lambdas. And we'll also talk shortly about using method references. They are even more concise than Lambda expressions, although they're somewhat less flexible. We'll talk about that later. So here's the example we're going to look at. This is going to demonstrate how you can work with multiple parameters much more compactly than by using anonymous inner classes. And we looked at this example briefly before. Now we're going to look at it in more detail. So again, we've got a bunch of names, and now we want to sort the names. Here's the old school pre-Java 8 way of doing a sort operation using a comparator and an anonymous inner class. And I think you'll agree with me that this is very, very verbose. In contrast, using a Lambda expression is much more streamlined, much more concise, since it omits the method name and also the other extraneous syntax that makes this so verbose and unwieldy and hard to see the forest for the trees in. You can also make things even shorter because you can use the type inference capabilities in modern Java in order to leave out the types and the type names altogether. So you can say S, T within parens, and that indicates that that's shorthand for string S and string T. So the Java compiler can actually infer or deduce the types properly. It's therefore a very good idea to use Lambda expressions instead of using inner classes. So whenever you're given a choice, you should try to use the Lambda expressions. And in fact, IntelliJ, as we'll see later, can actually make that transformation for you automatically when it will work in a seamless way. It'll do the transformation without you having to do the rewriting of the code. You can just click a button and it'll do it for you. So let's talk about how we can apply this. And for this, we're going to take a look at another case study. This is the EX5 project in the FP folder in my modern Java GitHub repository. So here we are in the EX5 project in my GitHub repository. And you can see what we've got here. This is the EX5 example, which shows how to sort elements in a collection using a Java anonymous inner class, which is the verbose way of doing things, or using a Java Lambda expression, which is much more concise. So here's the array we're going to sort and print. You can see what we've got here, just a bunch of names. We've also got a little helper variable that will make a copy of the array, so we don't have to worry about the fact that arrays are passed by reference in Java by default. We'll talk about suppliers later. For right now, just imagine this is a way to do a simple copy. And here's the program. We're going to start by calling sort inner class, passing in a copy of that array. And then we're going to call sort Lambda expression, passing in a copy of the array. And the first thing we're going to do is just print the elements of the array out so we can see what they are. So let's go ahead and take a look at sort inner class. This is the gratuitously verbose way of doing things. You can see this is the old school approach where we pass the name array as a parameter. We call the sort method on the arrays class, passing in name array, and then we pass in this comparator. And you can see how verbose and ugly it is. But you'll also notice if I hover my mouse over top of this, I'm not sure if this is showing up on the video for you, but if I hover my mouse over, it actually says replace with Lambda. So you can see you can automatically have IntelliJ or Android Studio, for that matter, do the replacement for you without you having to do that change yourself. Let me go ahead and print the contents of the sorted array. Let's now take a look at the more concise way of doing this with sort Lambda expression. Takes the same parameter, calls sort just like before, but this time we're going to go ahead and use the Lambda expression format, which will also perform type deduction. So we don't actually have to write out the long names here. Now, if I want to, I can use IntelliJ to expand those parameters if I want. And I can also use IntelliJ to do some other stuff. And we'll talk about some other stuff that you could do later when we get to the next set of discussions about method references. So that's basically what we're doing here. If we run this particular example, you can see it goes ahead and prints out the original array that's unsorted. Then it sorts it using the inner class approach. We end up with a sorted array. And then we sort it with a Lambda expression. We also end up with a sorted array. But I think you'll agree with me that the Lambda version is much more concise than the much more verbose anonymous inner class version.